Hello and welcome to Statistically Significant. In today's session, I will demonstrate how to use the Tora software to solve a simplex problem using the big M method. So this is our problem here. It's given minimize z equals to 2x1 plus 9x2 plus x3 with these two constraints. So here the number of variables is 3 initially and we have two constraints. So open the Tora software, then go to linear programming, go to input screen. Now let me give it a title M method. Number of variables is 2 and 3. We have initially 3 variables and 2 constraint equations. So we get the input grid and now we name our variables x1, x2 and x3. Now the objective function, it is maximize, but we have a minimize objective function, so we click on maximize to change it to minimize. Okay, the objective function is 2x1 plus 9x2 plus x3. So 2x1 9x2 plus x3, coefficient is 1 there. The first constant equation is x1 plus 4x2 plus 2x3 more than equal to 5. So now it is less than initially. Just click on it and then on your keyboard type the greater than sign and you will get it. It is 5 here. Then the second constraint equation, it's 3x1 plus x2 plus 2x3. Again, click on the greater than sign on your keyboard, more than equals to 4. So we have entered our objective function and the two constraint equations. Now we click on solve menu. No, I don't want to save my data. You may wish to save it. Now go to solve problem, algebraic iterations, and here you click on the M method. Now here Tora will ask you to enter the value of M. It is initialized as 100. You don't need to change it, or you may change it because M is generally a very large positive number. Now go to output screen. Now all iterations. Tora says iteration 5 is optimal. So we go to iteration 5 and here we see that our basic variables were x1, x2 and x3, but in the final solution only x3 is there. You see, in the final solution only x3 is there and the value of x3 is 2.5. So as x1 and x2 is absent in the final basic solution, they will be taken as 0 by default. So only the value of x3 will be considered and its value is 2.5. Now if we put x3 equals to 2.5 in our objective function, which is 2x1 plus 9x2 plus x3, it will return the value of the objective function to be 2.5, and which is here. You can see the z min value is 2.5. So this is how you use Tora to solve a simplex problem using the big M method. Now click on write to printer. It's taking a bit time, I know, but let's wait. Yes, the OneNote opens. Click on OK. So this is the original data, and here we get all the iterations and the final iteration with the value of the objective function to be 2.5 and the value of the basic variable x3 as 2.5. Now you can save it. You guys know how to save a data. That's it from this session. I hope you guys like this session. Do share and subscribe the channel. Thank you.